Well, thank you everyone for coming. I'm really excited to be here and to talk with you a little bit as we get this session kicked off about some of the technologies that we'll be using in the ReachNet environment and to talk in particular about a set of projects that I've had the pleasure to be able to work on. I'm getting a little echo. This guy here. Yeah. Okay, that's better, thank you. So I'm excited to talk with you about some of the underlying technology here. We're going to do a little bit of a fire hose. So I want to give you enough context that we know what problems we're trying to solve and how we're trying to solve them. But I also want to give you enough ground up that you can start to see how some of the technology fits together. I'll start out with a little bit of narrative on a project called Smart Health IT. And this was a project that was originally funded by the Office of the National Coordinator for Health IT. It was a project based at Harvard Medical School, and it was a 4-year, $15 million cooperative agreement between the ONC and Harvard Medical School. It was part of a larger program that got kicked off at the same time as Meaningful Use, trying to improve the state of the art for clinical record systems. So very broadly speaking, the 30,000-foot view is, here's our core focus. On the one hand side of this slide, we've got a whole bunch of different communities that could benefit from access to various kinds of clinical data. So we've got clinicians, we've got researchers, we've got consumers of healthcare, and on the other side, we have data that exists in a variety of places, in a variety of formats, and with a variety of different kinds of access control policies, rules about who can see those data and for what purposes. And our goal is to make it easier to connect across this divide here. So one way to look at this pile of data is to look specifically at the electronic health record systems. It's only one slice of the data, but it's an increasingly important slice as we've seen the rate of EHR adoption climb under the meaningful use incentives. And so one thing we can say, just to put a quantifier on this, is we've got over 1,200 certified electronic health records in the country today, and that's actually for a particular certification criterion. That's 1,200 systems that are certified to do patient-facing view and download and transmit, so sort of 1,200 systems that have to expose some kind of a patient portal. And in general, they all work a little differently. They do the same kinds of things, but they're independently developed, they look different, they store data in a different way under the hood. And if you were trying to build a tool to connect to these databases, if you had to write 1,200 different versions of that tool, it would be an intractable problem. So our focus really becomes on how do we define a core set of interfaces, a core set of what we call APIs, application programming interfaces, by which these tools can plug into various data systems. So we talk a lot about the word interoperability when we think about a problem like this. And the word interoperability means a lot of different things to different people. Often interoperability means I can send you a document from my system, and then you can put it on the screen and somebody can read it. And that is a really important use case in healthcare, to be able to send a document from point A to point B and have somebody read it. And it certainly falls under the umbrella of what people describe as interoperability. But to make this whole platform work, we needed something deeper. We wanted to be able to let developers build specific tools, apps that could plug into these systems. And we wanted the app to run the same way in one system or in another. And so we sort of made up a word, another 7-syllable word, substitutability. And the notion of substitutability is that you could substitute these apps. If you had one and it worked for you, that's great. But if a different app comes along that you would prefer, you can swap out the old one and switch in this new one. And that sort of encompasses the idea here of what we're trying to support. So what does it take to get that kind of substitutability of apps? If you're a software developer, what are the guarantees that you need? How do you know how to go home and actually start writing an app that can hook up to one of these systems? And we divide up these tools into 4 main buckets. So on the one hand, and this is the area where I'll probably spend the most time, is the bucket of clinical data. If you're developing an app, you need some guarantees about what sorts of data are available. Things like patient demographics, medications, problems, allergies, immunizations, vital signs, lab results. You need to know what kinds of things you can get. And then for each of those things, you need to know, well, how is it formatted? What sorts of data does a medication have? Does a medication have a prescriber? Does it have a start date? Does it have an end date? What exactly are those fields? So what are the data models that we're talking about? And then in terms of the vocabularies, how do I express to you the concept that the drug here was Tylenol? What code am I going to use for that? And an important focus for us when we think about clinical data is getting those details locked down tight enough that somebody developing an app knows what to expect. So if you want to interpret drug data, you only have to know about how one drug database works. And in our case, that's an open system maintained by the National Library of Medicine called RxNorm. And so you don't have to worry about the fact that 10 different hospitals might use 10 different codes for the word Tylenol. We say the data are going to be normalized to the point where you know what you're going to get. So if you had access to clinical data alone, that wouldn't be enough, because there are important policies restricting who can access data and in what circumstances. So we really need some security primitives in a platform like this. And in particular, the first thing we need is a way for a user to say, here's an app I want to use. I have access to the data. I want to share my access with this app or with this tool and allow end users to begin making some of those decisions themselves. Now, in reality, those decisions often aren't on the hands of a single individual. It might come down to a doctor working in the context of a hospital or the context of a clinic. And so there may be some policies from the organization, there may be some decisions that a user makes, but at the end of the day, we want to be able to explicitly decide what data to share with what apps. And so part of what the platform provides is this authorization level that allows that kind of decision to be made. And then the other piece of security that we focus on is the authentication problem, or you might think of it as single sign-on. So if I'm going to be using a dozen different apps throughout the course of my day, I don't want to have to create a dozen different accounts and register with each of those tools as a different user. Especially if I'm working in a clinical setting within my electronic health record system, I want to be able to run those apps inside my EHR and not spend any time signing into them. I should just run the app and the relevant data should appear where they're needed. So that's the goal. And that leads into the final bucket here, which is user experience. I described a bunch of different audiences on the sort of first iteration of this slide. There were clinicians, there were researchers, there are patients, and everybody has a different job that they're trying to get done. One of our core goals with this platform was to allow developers to integrate apps into the right place. So that integration could be very simple. For example, if you are making a patient-facing app that runs on an iPhone, you want to be able to just tap an icon on the iPhone home screen and use an app that's going to help you shop for the best prices for the medications that you take. If you're a clinician working inside of an electronic health record environment, you want to be able to launch these apps right from within your EHR. You don't want to have to leave and then start the whole process again each time you see a new patient. So part of what we provide in this platform is enough glue to put together the user interfaces and build a reasonable experience around the way these apps connect to healthcare data. So that's the really high-level picture. I'll tell you one story. This is a story about an article from Wired magazine published in 2009 or 2010. And Wired held like a little competition or a little showcase where effectively they said, here's a view of a laboratory printout. You can't actually see any of the details on this page, but that's sort of the point. There's a lot of blank space here. There's a bunch of numbers crammed down into the corner. And if you send this to a patient expecting this is going to change their dietary behavior because it indicates a high risk of heart disease, you don't expect this in the mail as an intervention to have much of an impact. So Wired held this sort of showcase where they invited information visualization designers to think of better ways to communicate this kind of information. And we had nothing to do with this process. My group at Harvard just read this article in Wired magazine. And part of the article was this picture. It was a view of how to represent a patient's cholesterol lab results in context. So this synthesizes some lab data, cholesterol, high sensitivity CRP, and then also some demographics. How old is the patient? Is it a man or a woman? A little bit of a smoking history. And it uses all these values together to synthesize, in this case, a 10-year risk of having a heart attack or a stroke. And so suddenly you can start to see information in context. So maybe you think this is a great visualization. Maybe you think, this was okay for 2009. Maybe you've got a better idea. But the point was this was a very concrete idea, and it was kind of interesting as such. It was published in Wired magazine as a picture, just like what you see here. And it was published on the web as a PDF, and it was made available under a Creative Commons license for non-commercial use. And so we thought, that's interesting. This is an example of somebody's hard work that went into producing a design. We think it's a neat design, but ultimately it's just a picture. And we see the same thing happen in research publications all the time. You get a large data set, you do an analysis, you come up with a new risk model that could be clinically relevant, and then you publish a paper about your new risk model. It's important. It's a good way to get the message out. This is how the academic community works. But taking a paper that was published in an academic journal and translating that into clinical practice is very hard. Same thing with a picture like this. So we thought we wanted to demonstrate what it would take. Using an app platform like the one we were building, we should be able to take a picture like that and turn it into an app, turn it into a tool that can be fueled by data directly from the EHR system. Let me see if I can flip to the right tab here. So this is an example of that image reimagined as a smart app, an app that can grab data from the EHR to populate the positions of these numbers and these fields. And suddenly, instead of just being a static picture, it starts to be something interactive. We can do a what-if scenario. If you've got a smoker with a history of heart disease and these kinds of cholesterol results, 67-year-old man, he's got a 60% chance of having a heart attack or a stroke in the next 10 years. And suddenly, we go from just a static calculation of risk to a consultation tool. You could have a conversation between a clinician and a patient and say, if you get your blood pressure even moderately controlled, and if you quit smoking, you can cut your risk of having a heart attack by a factor of 3. So this is the kind of thing that we wanted to enable. We wanted to let smart people with good ideas about how to work with clinical data express those ideas not just as pictures and not just as an article in a journal. Those things are great, they're important, but we want to make it really easy to translate those ideas into real apps and tools that can run inside of healthcare systems for patients, for researchers, and for clinicians. So I'll just make this point explicitly. If you have this kind of ecosystem where apps can easily plug into electronic health record systems and other kinds of health information technology, this idea of substitutability gives us two things. If you're building an electronic health record system, you like the idea of substitutability because substitutability means choice. Your users get to pick which apps they prefer, and if a better cardiac risk app comes along next year, you can get rid of your old one and start using the new one. So substitutability for the sort of EHR and clinician and researcher community means you can choose which apps to use. But if I flip this picture on its head, think about somebody developing an app. And from this perspective, substitutability means reuse. Because suddenly, this app doesn't just run in one place. It doesn't just run inside of our electronic health record system at Boston Children's Hospital, but it can run across any system that supports these APIs. So what might be an intractable problem, I might not have the budget or the time to spend developing a tool that only runs one place with a very small audience. Well, if I can leverage that development effort and build a tool that can be used across a much bigger audience, suddenly it becomes practical to start thinking about building some high-quality, polished tools that will really make a difference in terms of clinical practice. So I'm only going to say a little bit about the earlier incarnations of our platform. When we started this project in 2010, we did a survey of the ecosystem and said, what are the standards and tools that already exist that we can use? And I'll just say we weren't enamored with the model of document-based exchange. So some of the best interoperability tools in 2010 were about sending a document from point A to point B. Parts of it worked well, parts of it less well. But from our perspective, sending a document from point A to point B wasn't really the problem that we were trying to solve. We wanted to let an app query for the particular bits of data it needed. A blood pressure here, a cholesterol there. Let the app drive the decision about which things mattered so it could get just the components that were important to it. And the document-based exchange model is different. Document-based exchange says, I've got a document for you, here you go. It's important, it's useful, but it wasn't where we were trying to go. And at the time, you also had to buy these standards and specifications to use them. I'm happy to say this is no longer true. HL7 has now made these document exchange specifications available for free, so anyone can use them. So I won't tell you too much about the history, because I'm excited to tell you about where we are today, which is a platform where we've got an international community through a project called FIRE-FAST, Healthcare Interoperability Resources. This is a community that we joined back in 2013 as an early draft of the standard was coming together. And we were really excited about FIRE because it solved a couple of basic problems for us. The first thing that FIRE did for us was to provide an openly licensed standard, something that anybody could view on the internet, could download, could implement without having to pay royalty fees or licensing fees. And that was really important to our core mission working on smart health IT because we wanted a platform that was open for the world to use and to implement. Second thing FIRE did was to provide a set of clinical data models, which FIRE calls resources. And I'll show you what some of these look like in a little bit more detail. But these were the building blocks that we needed to support apps that could query for a cholesterol value or a blood pressure. And secondly, FIRE provided a built-in REST API. And we'll show you examples of what that looks like throughout the course of the morning, but a specific way for apps to query for the data that they cared about. And then really the most compelling thing about FIRE was this community. There's an international group of experts from various domains in healthcare who have been collaborating together for now 3 or 4 years just on this project. And there's experts in any domain of clinical knowledge you're interested in. And the fact that this community has come together to start building out an open set of models. And even though a lot of problems have been solved, we know there's a lot of problems outstanding. And there's a real work in progress aspect to it. We're making changes, we're improving things over time, and there's a great mindset around making those incremental changes and improvements. So I want to show you a couple of examples from the FIRE specification, just to orient you to what FIRE is and why we're using it for our app platform. So the cool thing about FIRE, first of all, is it's a unique acronym, F-H-I-R. People find it hard to pronounce, but it's very easy to Google for once you know how to spell it. And this is almost a trivial point, but I make it because it stands in distinction to previous healthcare specifications. You can Google for FIRE, and what you get is the spec. So I can click here, and now I'm reading the FIRE spec. If you try doing this with CDA, even though it's free now, the experience is very different. You Google for CDA, and eventually you find the HL7 webpage, and if you sign in and answer some marketing questions, then you can download a zip file with a 600-page sort of PDF file that you can extract and read. So it's all available, but FIRE is openly available in a way that really is game-changing for software developers who are used to things that work this way, who are used to things that are documented openly. We can send a link to a specific page. If you've got a question about how something works, we're in the web browser here. I can just copy the URL that I'm at, and I can send it to somebody and say, I don't understand the thing that I read right here. And that ability to share content and to link is, like I said, it's almost trivial to point out, but it's incredibly powerful. So let me give you a very quick tour of the FIRE specification. And I'll say, from my perspective, the things that are the most useful in FIRE are these sets of clinical data models or resources. And so in FIRE, resources are put in a couple of categories here. Administrative and clinical are probably the most relevant ones for us. And in each of these categories, there's a set of these building blocks. So on the administrative side, there's things like patients and healthcare practitioners and locations and organizations, the building blocks through which a hospital or a clinic might be defined. And then on this clinical side, there's things like an allergy intolerance, a condition, which is a problem on a patient's problem list, a procedure that might have been performed on a patient, a whole set of resources around ordering medications, prescribing drugs for patients, dispensing drugs at a pharmacy. So these are the kinds of clinical resources that FIRE defines. And I want to just dig in and show you a couple examples. So the simplest thing I could show, well, the most interesting thing I'll show you actually is probably medication order. This is the way that you would represent a prescription for a patient. And I won't take you through it in much detail, but I want to describe the overall layout so you can start to get a feel for what FIRE is and what it defines. So in this case, we're looking at the definition of a resource called medication order. And if you don't know what that means, there's a little paragraph at the top that says the idea of orders is to describe instructions for administering a medication to a patient. And you could think of this as a medication prescription. So that's a little bit of context. And there's some background saying how medication order relates to other resources. But the core content of the FIRE specification is tables that look sort of like this. This is a table that says, what's the data model for a medication order? If I want to share information between one healthcare system and another, or between an EHR and an app, or between a research database and a tool that's going to compute a risk model, what are the data fields that are going to be available on a medication order? And so in this case, we can read down the table and say, okay, a medication order has a date on which it was written. It has a date on which the order ended. It has a reason that you stopped it. Importantly, it has a patient. So what patient is this order about? It has it has a prescriber. So who wrote this prescription? And on down the list. There's a pretty rich data model here for describing the relevant things about a prescription that you would want to communicate between two parties. And then each of the fields in this data model has a type. So a simple one, for example, might be the date written. Its type is a date time. And if you don't know what a date time is, you can click on this word here, date time, and you'll be taken to the FIRE data types definition that says exactly what a date time is and how it's represented. And so you can learn, for example, that this could just be a year and a month, or it could be a specific day. All those things might count as a valid date time. And then if you don't know what a patient is, for example, what's a patient? Well, in FIRE, it's a reference to another resource. And this is an important point about the way FIRE works. Rather than sending you a document with all of the relevant information in one place, rather than repeating the patient's name and medical record number and address and phone number every time I share a prescription, Instead, FHIR provides a link or a reference to a patient resource. So the patient can be separate from the prescription, and the prescription can point to the patient. It's very much the way that the web works, where you have a web page that links to another web page, rather than embedding all the content from all the different places on the web that you want to talk about. And so you can click through in the specification just the same way. I can say, well, what is this patient resource? And I can click here, and now I'm on a new resource definition page for patient. And patient resource has a table just like the one I showed you a moment ago, but this time describing all the data elements on the patient resource. So I won't go through the details. But that's the basic way the FHIR specification works, and there's about 100 resources today that are defined at this level of detail. In addition to these data models, if I scroll down to the bottom of any one of these resource pages in the FHIR specification, I'll find a set of what are called search parameters. And this is a built-in way that FHIR provides to index resources, to make them searchable by outside tools. And the idea is to give outside tools a consistent set of expectations about how they'll be able to search for resources. So in the case of a patient resource, these are the things you can search by. I can search for patients by their given name, so their first name, or by their family name, or by their gender, or their email address. I can search for patients based on their phone number. There's an explicit list of fields that I'm allowed to search by, and FHIR provides that out of the box so that we don't have to negotiate every time we think about a new resource about, okay, I want to search by this, okay, well maybe we'll enable that in our server, maybe we won't. The idea is that FHIR defines up front a set of these search parameters that we can use to find resources. So that's a very brief tour of the FHIR spec. I'll encourage you, if you do dig in, to actually read this welcome paragraph. It's a short paragraph, but it's got 3 or 4 high-yield links in it that people often miss when they're looking at the spec for the first time, because these pretty pictures do draw the attention better. But the executive summary and the introductions here for developers and for clinicians are a great way to get oriented to what's happening in the specification. So I promised you a fire hose tour. That was the rapid fire tour of the FHIR site. Okay. We're using FHIR under the hood in a couple of ways. I'll just show you the picture. We're using FHIR as the way that third-party services can get access to these underlying EHR systems. So I'll kick you on a quick tour through this diagram to try to give you a sense of how these parts fit together. How do FHIR and SMART relate to each other? So on the one hand, we've got a set of applications. They could be web applications, like the ones in this box here. They could be mobile applications, like the ones in this box here. But wherever the app is running, whether it's on the web or a mobile phone or on a desktop computer, these apps connect to a FHIR server that's protected with a set of security protocols using a standard called OAuth 2. And so what SMART defines is how these security protocols work, and also a set of what FHIR describes as profiles, a way to lock down things like vocabularies and to say which fields of each element are required versus optional. Because if you dig into the FHIR specification, you'll see that almost all the data elements are labeled as optional. Because some people using FHIR might want them, other people might not want them. FHIR is an international specification, and to get that kind of international agreement, you have to loosen up the parameters to the point where they serve everyone's needs. So it's great, it's important, but part of using FHIR in a particular use case like we do for SMART is locking those details down. And so we provide a set of profiles that are very much aligned with meaningful use, common data set requirements that lock down things like vocabularies and which fields are optional versus required. And under the hood, you might have any number of different systems that are implementing these APIs. So SMART on FHIR, at its core, is a specification. It says how one system should talk to another. We have a sandbox environment. We have a bunch of tools where people can explore this environment. But in the real world, we don't have a cloud-hosted service where all the health data come to be exposed. In the real world, we say that individual healthcare systems, individual EHR systems, individual research data warehouses support this API. And each one exposes it themselves. And so when an app is running against a SMART system, it's only running against one SMART system at a time. There's not some giant database in the sky, at least not the way that we envision this platform. And the idea is, Cerner is working on an implementation, and various other companies. I'll talk a little bit about the community, but the important message here is in the bottom right, your system here. Anyone can build out support for these APIs. The technology is all open, and we've got some tools to make it easier to do. So I won't take you on a tour through what the SMART REST API looks like, the way that you actually query for resources, but there's some links from the slides. You can check them out on your own, and we'll have time to dig into these in some of the discussions later this morning. What I will show you in just about 5 minutes is a gallery that we've launched at the Smart Health IT website to show off some of the app development work that's happening in the community. And so this gallery is open. Anyone can come here and submit an application to it. And there's no fee. And the idea is simply to showcase what people are building with Smart on Fire. And there's a couple of categories that are on the left here. So for example, we can look at a set of open source apps, many of which are apps that we've built in my group at Harvard, but others are submitted by folks from the outside. I'll show you what a couple of these look like. So for example, this is an application, blood pressure centiles, that we deployed at Boston Children's Hospital in response to a set of requests from the cardiology department there. The cardiologists wanted a way to make the diagnosis of hypertension in children in a more accurate way and in an easier way. Because to make that diagnosis in kids, you need to know a bunch of data. You need to know the blood pressures, but you also need to know how old a child is, how tall they are. You have to know, for example, for a particular age and height and gender, you can calculate a percentile. You can calculate whether this value is high or normal or low. And so every EHR pretty much stores all of those data, but the EHR systems don't help you synthesize them. They don't help you make the calculation based on that data to actually determine whether this blood pressure value is normal or too high. So this is a tool we built working with the cardiology department at Boston Children's Hospital. And it's something that we iterated on the design of over the course of a month or so until we got to the point where it was reasonably answering their needs. It provided a table view so you could look up a history of values from the EHR. You could do some plots. You could do some what-if calculations on the fly. And this is a tool that we deployed at Boston Children's Hospital, and it's now being used in the course of routine clinical practice. And it's the subject of a research study that's looking at what happened in terms of hypertension management in the interval before and after the app was deployed. So that's an example of an application that was really driven by clinical need. It helps visualize the data from an EHR and make use of it, but it also then becomes an interesting focus for a research study. I'll show you a couple other sort of research-focused tools. So one is an application that's being built or sponsored by Duke Medicine. And this is a tool that's looking at educating patients about the medications that they're taking, looking at how well patients know what medications they're supposed to be taking, trying to figure out how well the system, the EHR system, agrees with what's in the patient's head. So this is a tool that was built to provide an exercise for a patient to do as part of a research study. So it grabs some data from the EHR. When you launch this app, it grabs the medication list that a patient is currently taking, and it allows a clinician or a research coordinator to set up an exercise for the patient to take. And they would either do the exercise on a mobile device by scanning this barcode, or clicking through, they can do it in the web browser just the same way. The exercise basically shows you all the meds that are in your pill box. And as a patient, you try to say, oh yeah, the lisinopril I take at noon, and the donepezil I take at bedtime. And you sort of say, oh, well, I forget when I'm supposed to take the hydrochlorothiazide. I need a hint. And then you get a hint that shows you what you're supposed to take. And then eventually you say, okay, I'm all done now. All these interactions are recorded, and the interactions are shared back with the research coordinator, so that after the fact, the research coordinator can review what happened on this particular patient experience. So this is somebody who spent 18 seconds interacting the exercise. They took 3 actions, and they're going to start to develop a correlation between these kinds of metrics and how well a patient does on adherence metrics later on. The cool thing about this story is this is a pretty in-depth tool. It provides a pretty rich sort of user interaction, and it's something that could be built only if access to the EHR data was really easy, because you're not going to get a clinician to enter all this information in by hand. But if you had to do a custom integration with the EHR system, if you had to negotiate access to an interface that was going to expose these medications, if you had to get on the phone with the EHR developer to talk about exactly which fields were going to be there, and then pick up the phone again because something was missing or it was coded wrong, it would take far too much time and money to build an app like this just for a one-off research study. But if the APIs actually work, if they're readily available and consistent, then you can get an app development team together and use those APIs to build a tool like this in pretty short order and on a relatively small budget. So that's the sort of notion here, is people can start to build tools that solve their own problems when you give them access to APIs like this. And I'll encourage you to check out the gallery. It's gallery.smarthealthit.org. Let me share a couple of closing thoughts, and then we'll have 5 or 10 minutes for questions. So these are just some lessons that we've had from our experience over the last several years, trying to build an API that solves enough problems for enough people, and yet is also simple enough that it can be implemented. So the first lesson here is Our platform provides access to structured data. There's some security considerations built in because those things are really essential. But there's a lot of features we don't provide. For example, handling complex ordering workflows by which orders are entered into the EHR system, or allowing a system of app-to-app communication where multiple apps running on the screen at the same time can interact with each other. We haven't tried to do those things, and we've gotten by pretty well leaving those things out of scope. And eventually we will start to address some of those things one by one. But it's an important lesson to say, what's really critical here? What's the minimum set of problems we can solve and still make a big difference? And then focus on solving those problems as well as we can. Number two is the experience of software developers is really critical here. And our goal is to make a platform where people can start building apps on top. And if the documentation isn't right, if the interfaces aren't easy enough to use, then the fact that something is sort of theoretically good doesn't make much of a difference. It has to be usable. And then finally, the community experience has been incredibly important for us. We've been working with a pretty big community, including the HL7 Fire World, including a set of electronic health record vendors in the US in a project called Argonaut, which includes Epic and Cerner and Athena Health and Meditech and McKesson and many others, including a set of healthcare provider organizations, including Hospital Corporation of America, including some of the data networks like SureScripts, including some folks from pharma, including some content and app development community. And we've actually got what's called our advisory committee on the Smart Platforms project who are sponsoring some of this work that's still happening at Harvard Medical School and at Boston Children's Hospital. So we've been really excited to be able to participate in this growing community around the development of apps. And with that, I think we've got 10 minutes for questions if anybody wants, or comments, by all means.